Thank you, Amy. Really appreciate it. It's just a thrill to be able to speak here. Let me get my screens up here and hopefully you should be able to see the slides now. And yeah, we're going to talk about advancement through collaboration, engineering as a team sport in 2025 and beyond. Um, Engineering and technology in general have always been pretty much team activities, but the nature of the game has been changing a lot. The way that we work together as teams in technology is changing. And so this is a great time to take a look for everybody who might be anticipating a career in engineering or maybe in the early stages of a career or really anywhere at looking at how we play on the team in order to get great engineering things done. My background, by the way, is I'm currently a consultant with my own independent practice, working mostly on uh, data analytics, data science, and software development in the healthcare industry. But I was earlier a professor at DeVry University, and have had the pleasure of working with a lot of students and getting them started on their careers in engineering and software. So kudos to everybody who's walking that path. And as Dr. Tidwell said, please feel free to put any questions or comments in the chat, and we will deal with them toward the end. So I thought it would be good to start off with at least a definition of what we're talking about here with collaboration, teamwork, and synergy. Collaboration is just working together in a particular way in order to complete a task or achieve a goal. Teamwork is, again, that collaborative effort working toward a common goal as a group or as a team. And then what we're really trying to get to is synergy, which is a whole that's greater than the sum of its parts. So, and this is the really important thing about collaboration. It's different than simply cooperating, right? It's working together in this enmeshed, intermingled way so that we get the benefit of the team rather than just adding up the parts of the whole. I know I've seen student teams and even professional teams in the workplace approach projects through a divide and conquer type strategy. Admitted, I've done it myself, where you just divide up the pieces of the work. Everybody gets a piece, everybody does their piece, and then you cram them all together at the end. Well, that's great. That gets you a product, but it's not really collaboration and it doesn't really get you to synergy because then you're just getting the sum of the parts. It's where you work closely together in an intermingled, dynamic, back and forth way to jointly produce the product that you really get this synergistic effect. The projects where I've worked on, say, I've done the software, someone else has done the electronics. If another engineer did the electronics, handed it off to me, and then I did the software, that usually produces an okay result. But if the electronics person and I are working shoulder to shoulder at the bench, kind of co-developing the hardware and the software so that they work as smoothly as possible together, that's when you get that great home run synergistic result. I hope that makes some sense. No less than Steve Jobs said, great things are never done by one person. They're done by a team. So it really is all about, in order to achieve what we really want to achieve, being able to work together as a team. And that goes kind of against the sort of reputation of engineers and technical people as, we kind of tend to be, with some exceptions, maybe a little on the introverted side, a little on the nerd side. But it's really through learning to work together as a team that we're able to reach our full potential. So there's two kind of burning questions that I want to deal with in the next few minutes. One is, what do these things that we're looking for, synergy, collaboration, and teamwork, actually look like in modern engineering? And then secondly, given that, how do you get ready to join the team and play to your fullest on the team? Let me ask you a question right now. If you had to describe teamwork in engineering in just one word, what would it be? Just go ahead and throw your answers in the chat. Let me see if I can make sure that I'm seeing the chat here. Uh, and I'm not actually seeing it at the moment.
I
So
can read you the
yeah,
words.
if you could give me a few, just a taste of a few of the responses.
Communication, exponential, scheduling, a lot of communication, technical scheduling, communication, communication, communication.
All right, all right. So
Energy.
yeah, perfect. Sounds like communication is the winner, which is terrific. So I'm going to give you three other words, though, to get us started. Fast, fluid, and fully engaged. When I started out in engineering back when dinosaurs ruled the earth, it was much more common for the engineering sport to look more like a relay race, where, as I described before, one person or one part of the team did their thing, then handed it off to another part of the team. They did their thing. Everybody stayed in their own lane. You know, hardware design, mechanical design, software, and your only real interaction was at these handoff points. And that's really not going to work in the dynamic environment that we're in today. So now you've got something much more like a soccer match where there's constant interaction, there's kind of an overall plan, but not a lot of structure. The details are changing moment to moment, and you've really got to be heavily involved, constantly engaged, and adapting to what everybody else is doing in order to achieve the common goal of getting the ball in the net or getting the product design across the finish line. And let me give you an example of that, which is, let's say we're developing a drone, maybe something like, this particular one I think happens to be by Skydio, that was being used by the Coast Guard in the picture that I lifted this image from. So what are some of the different engineering specialties that we'd have to create a drone? Well, it's a lot. You've got to have somebody who knows aerospace because the thing's got to fly. You've got to have software. You've got to have telecom and radio frequency engineering because it's got to communicate. You've got to have a systems engineer to make sure everything works smoothly together. It's all about cameras and imaging, and so you've got to have an expert in that. You've got to have somebody who knows mechanical systems for the motors and the control systems. You've got to have materials engineering to make sure it's strong enough to hold together and light enough to fly. You'd better have cybersecurity or it's going to get taken over by a hacker. You've got to have somebody who knows human factors and user experience so that the controls are usable. Um, and then beyond that, you've got to have AI and robotics because modern drones have to have at least some degree of autonomy. They frequently can take off themselves, land themselves, maybe even guide themselves using AI to reach a target or achieve a mission objective. Um, so that's a lot of engineering going on and a lot of collaboration because no one person is going to be an expert in all those fields. And at the same time, beyond the engineering team, in the business world, you've got a project manager that's overseeing the overall development. You've got manufacturing that's going to have to be able to make the thing when you get it designed. You've got to coordinate with supply chain management to make sure that the parts can be sourced. Somebody's got to be able to distribute it, which means looking at the packaging. How can it be shipped? How do you protect it in shipping? Marketing's got to understand it in order to sell it. They've probably had input into the specifications in the beginning, so you're developing something that the market actually wants. Finance has to keep track of the money, keep you on budget. Um, Legal and regulatory compliance with something like a drone. You've got the FAA, you've got the FCC, you've got numerous regulatory bodies and laws that you've got to navigate. It's got to fit into overall corporate strategy. Salespeople have to be trained on, how to sell it, how to customer support has to know how to support people who are using it. HR has to recruit the people on your team and make sure that you've got the right engineering talent. And then you've got to have IT and cloud infrastructure on board because all of these things now operate through the cloud. downloading flight plans, coordinating activities, and so on. So there's an awful lot of collaboration and teamwork involved, both inside engineering and outside engineering with the larger business community in order to get a product like this across the finish line. Just to give you an idea, and these are informal estimates from talking to people in the industry, typically on a team like this, you might have 55 to 100 engineers, and the whole project might take 18 to 36 months to take a new drone project from concept to production. Um, so definitely a team sport, and definitely getting all those people to work together successfully is critical to success. Here's another question for you. Who do you think was the first engineer? And again, if you could just feed me a few of the guesses from the chat as they come in. Any ideas?
Not yet. So I'm waiting for
Not
chat.
yet. Okay. Well, we
Uh,
probably,
well, I'd start with Franklin.
okay, not a bad guess.
Da Vinci.
Yeah. It actually goes back a lot farther than you might think.
The
Uh,
Egyptians,
E-
Adam.
Egyptians. Okay, Adam is actually great. I like that because we don't know who the first person was to throw a vine over the top of a tree branch and call it a pulley, but that was probably really the first engineer. But the first engineer that we can name was this guy named Imhotep in Egypt, who was doing pyramid design back in the 27th century BC, so almost 4,000 years ago. So this is a very old profession, but we keep adding all of these new fields and new specialties to collaborate with. Just some engineering specialties that have emerged or have become more prominent in just the last few years: AI and machine learning engineering, data engineering, cybersecurity, quantum, small now, but growing like crazy as quantum computing actually becomes a reality, robotics, sustainability engineering, all of these things. So there are more and more specialties every day that we need to collaborate with and involve in our projects. Increasingly, those projects are being managed using what we call an agile approach. This idea of we iterate frequently, we throw something out there that's a partial deliverable, we get feedback on it, we take that feedback back in, and then we improve it, rinse, cycle, and retreat. Not sure where my the red marks on my slide are coming from there, but yeah, so and increasingly, certainly in software and IT, it's almost guaranteed you're going to follow one of these agile processes. Engineering in general, maybe about half of projects these days are uh, agile. Other types of business projects are increasingly adopting agile. So you're going to be operating in these self-organizing, cross-functional teams that emphasize close collaboration both within the team and with your external stakeholders. And that's just the way we get the work done these days. Let me see if I can get rid of, there we go. Okay. And increasingly also, we're collaborating with remote colleagues, even colleagues around the globe. There's been this huge tension ever since the pandemic, right? In the pandemic, everybody went fully remote. And everybody thought that it was going to be that way forever. And so, people were like moving to tropical islands and doing engineering work. Uh, Now there's this huge backlash from management types who are saying, we want everybody to return to the office. The dust seems to be settling somewhere around, with most people doing some kind of a hybrid structure. This is a recent survey of software engineers specifically, who are probably some of the most remote prone engineers. Obviously, if you have to work in a lab or you need big specialized equipment, then remote may be off the table. But it looks like about 50% of software engineers are hybrid, where they're on site some of the time, off site some of the time, 30% fully remote, 20% maybe, claiming at least to be fully in office, whether they really are or not. Um, so collaboration skills, with colleagues who are not sitting in the cubicle beside you, being able to collaborate over Zoom calls like this one, using remote tools, using distributed tools, is going to be increasingly important. And you really need to be able to navigate different cultures, different time zones, all the challenges of working with people around the world, because science and technology is not confined to one nation state. There is engineering expertise all around the world, and companies are tapping into that. And so uh, I've personally collaborated over the course of my career with people in, let's see, Canada, Mexico, Japan, France, Germany. I actually know some great bars in Hanover. Um, Sweden. So you need to adapt to the challenges of, people who are working different hours, who come from different cultures, speak different languages. That's actually an area where AI translation can help a lot, but you need to be aware of people may be using different measurement units. There was famously a Mars probe project that crashed because one team was using English units and another team was using metric units, and somebody messed up the conversion. So you need to be aware of those kinds of risks. I've had issues on cross-national teams with date formats. If you said deliverable is due on 6/7/2025, does that mean June 7th or does that mean July 6th? Depends on what country you're from. So a global awareness of all of these things and how to navigate them is becoming increasingly essential. And yes, there's going to be AI on the team. Um, let's address the large language model in the room. Um, Here's an example of, in my field, software engineering, an AI coding assistant, Microsoft Copilot, being used to generate some data validation code in the Visual Studio Code environment. So the developer just tells the AI, write me some code in JavaScript to make sure that submitted value for a phone number is in valid format. And the AI spits out the code and just, once it's approved, just moves it directly into the project over here. Um, Fantastic stuff. A little bit of scary stuff if you've hung your professional identity on that you're a great coder. Um, but my experience is this is really a positive. It speeds up the pace, probably. Um, there's actually one recent study by an organization called Meter, METR, that found that in some circumstances, software developers using AI tools were slowed down by 19% instead of sped up because they spent so much time checking and debugging the AI generated code. So some of these kind of hyperbolic claims about productivity, I think, are exaggerated. But in general, it's a productivity tool, and it's another tool that we all need to learn how to use and work with. Here's an example for mechanical engineering. This is Autodesk's Fusion 360 3D CAD application with AI generating a series of design alternatives. You feed it the requirements that you have for the design, and it will actually create a variety of different shapes that could be used to satisfy those requirements. So it's a terrific AI generator. It's terrific for creating kind of boilerplate or routine stuff that you don't have to spend a lot of time on. Um, but it is also potentially a risky new error source. There are, again, studies that indicate that AI generated code, again, on the software side, contains significantly more security vulnerabilities and different kinds of security vulnerabilities than human generated code. And so at this point, at least, there's still a need for humans in the loop in everyday engineering. But if used correctly, it can be a real force multiplier and potentially a productivity multiplier. Uh, I do want to address, because if you're out there looking at things, you can see some crazy claims about AI replacing entry-level jobs. This is the CEO of the largest web services provider in the world, Amazon web services, saying that AI replacing junior employees is the dumbest thing he's ever heard. And I think he's, on the right track there. Um, I just saw an article in the IEEE Spectrum magazine today about a new study from MIT, Berkeley, and Stanford, why AI isn't ready to be a real coder. So I think the sane voices on this are saying, uh, yes, this is a very helpful productivity tool. It's not a replacement. And if someone's saying that it's going to take everybody's job, at least in the next few years, you maybe need to look at what financial incentives they have for making some of those kinds of claims. Um, my experience has been most of the job of being a software developer has never been writing the code. It's been understanding the problem, working with people to understand what they need, and then designing a good engineering solution to that problem. And the actual sitting down and typing on the keyboard is really only a minor part of the job that I'd be happy to see largely automated away. I've seen many productivity improvements in software development. When I started out, I had an embedded systems job where most of my code was written in assembly language. If you've never touched assembly language, it's ugly. It takes like 6 or 7 lines of code to add two integers together. Um, and now, with a good Python library, you can do matrix multiplication of huge matrices in, one line of code, or you can ship something off to an AI library and have it run a complete analysis and bring you the results back. So, you know, all of those productivity improvements have not resulted so far in fewer developers. They've resulted in more developers and greater use of software and greater need for people who can solve problems with software. So my take, at least for now, is that's where this is headed, but it's going to be a bumpy ride, and it's certainly going to be interesting over the next few years to see how it all develops. Just to mention a couple of other technologies that I think are going to be are currently big in engineering and are going to get bigger. We don't really hear that much about virtual worlds these days. Mark Zuckerberg is kind of no longer talking about his metaverse, even though he changed the name of the company to Meta because he's fully pivoted to AI. But there is still a lot of interesting work going on with virtual reality and with augmented reality as tools to be used in the engineering process. Here's a picture from a VR design evaluation system that Hyundai and Kia have debuted. Basically, engineers can put on VR goggles, just like the ones that you use to play a VR video game, but they can project an image of a vehicle. They can collaborate in real time in the cloud on a three-dimensional projection of a vehicle that doesn't yet exist. They can visualize a design. They can see how the parts fit together, how to take them apart. What would it look like if we tried a different shape for this gear? Right? So amazing potential there for improving the engineering process for vehicles. On the augmented reality side, here's a construction engineer out in the field overlaying the CAD model of a structure onto the actual site out in the field. So you can make sure that everything is going in place correctly, that the ground is being dug out correctly and leveled correctly, and so on. So again, huge potential for increased use of these kinds of tools to aid in collaboration and speed up the engineering cycles. And then we also have 3D printing, although a lot of the buzz about this has been more on the manufacturing side. Um, in actuality, a lot of the use of 3D printing now is coming on the engineering side to speed up prototyping, right? I mentioned earlier the agile process of do something quickly, put it out there, get feedback, bring it back, iterate on it, and improve it. 3D printing for anything that involves mechanical parts really speeds up that cycle because you don't have to do a design, send it off to the prototyping shop, wait a few days or a few weeks for them to build a prototype and then bring it back to you. Instead, you just plug it into the 3D printer and you get something that you can actually put your hands on and work with in, a matter of minutes or maybe a matter of hours. My dentist's office has a 3D printer for printing dental crowns. So instead of coming back a couple of days later, I had the pleasure of having a root canal a few days ago. Don't recommend it. But instead of having to do two separate appointments, I just sat in the dental chair and scrolled through emails on my phone for an hour while the dentist designed the crown in a CAD system, printed it up on the 3D printer in his office, and then brought it back and glued it onto my tooth. So, the technology is becoming more and more widespread, and it's incredibly useful for speeding up the engineering, design, and prototyping cycle. And I think anything that involves mechanical design and packaging, anything like that, is going to increasingly benefit from this technology. So our burning question number one was, what do synergy, collaboration, and teamwork look like? Well, they look like being fast, fluid, and fully engaged, more like a soccer team than a relay race. It looks like having to span and communicate across many engineering disciplines and also business areas with new engineering disciplines and specialties that we need to integrate into the process, emerging all the time. It's increasingly organized as these agile projects where we do quick sprints. We don't wait for perfection. We do a sprint, we kick something out, we get feedback on it, we bring it back, we repeat the cycle, we improve it until we get our finished product. We're increasingly collaborating over digital connections, connecting remote colleagues and hybrid workers and doing that potentially across the globe. And we're increasingly leveraging these new technologies, AI, augmented reality, virtual reality, 3D printing, and undoubtedly many more, continuing to come online. How does that sound? Sound exciting? I think so.
Very much so, sir.
Okay. So that brings us to our second burning question, which is, how do you prepare to join the team? And one way, I think, is to make yourself into an M-shaped person. There's this kind of interesting way of visualizing people's skill sets. A specialist is an I-shaped profile, deep knowledge in one area, not much going on outside of that area. And then for a long time, we've been encouraging people to enable them to work better in teams and be more collaborative, to become T-shaped, where you have your specialty area of expertise, but then you have broader knowledge across a range of areas, and so you can at least speak the language of people in other disciplines that you are collaborating with and get that communication going. But as the world gets more complex, as the speed of collaboration increases, we're going to need people with more what we call M-shaped profiles. And here it helps to think of it more as a lowercase m, where you've got, again, that broad range of general knowledge, but then you have multiple, maybe three, maybe even more areas of fairly deep expertise. And this could be expertise in different engineering specialties. So it could be, for example, you might know software, you might know cybersecurity, and you might know sensor design, which would make you very versatile. Or it might be maybe you know software development, but you also have taken some classes to become an Agile Scrum Master, and so you know Agile project management, and you can fulfill that role. and maybe you are a great business communicator. You can really do a great presentation, or talk to the people from finance or the people from marketing and get them to understand what's going on in engineering and be that liaison person. So yes, start out T-shaped, right? Develop that deep expertise and that broad range, but then don't stop there. Keep, finding more areas that interest you, satisfying that curiosity, doing those deep dives, and building up additional areas of expertise that will make you even more valuable and an even better collaborator. Work on what are called soft skills. I actually absolutely hate the name soft skills because it implies that they're kind of soft and squishy and not as essential. I would prefer to call them durable skills, but that's the kind of the term that everybody knows and understands when we talk about what soft skills are. So to make this specific to engineering, there was a study a couple of years ago where the researchers actually asked 500 companies who employed engineers, what is the relative importance of, I think they asked them about 26 different soft skills. And these are the 5 top ones that came back. There's working in teams. So that's our theme for the day is number 2. But then they also asked them, what's the gap between the importance of skills and how proficient your entry level workers are coming in using those skills? And so that's where you can really set yourself apart from your competition by being good at, there's communication, which we talked about earlier, time management, writing, dealing with uncertainty, and again, communication. So those are the skills where people are really lacking, people who are able to do those things, and where you can really make yourself stand out. And again, just to touch on this idea of AI, 80% of people surveyed, this was a different survey, but 80% said that soft skills are becoming even more important than ever as we increasingly use AI. So that those people-to-people skills, as a lot of the technical work gets handled or the routine work gets handled by AI, it's being able to work with people that's becoming even more valuable. And then you want to be able to build bridges to the business side. We talked about this a little bit with the drone example, that you have to collaborate not only with other engineers, but also with your colleagues in the business world. So things like learn basic finances, how to read a financial statement, learn how to understand what the customer wants, learn some marketing, learn what your competitors are doing, learn about regulatory and risk assessment, right? How to stay legal, how to stay safe. Learn about your operations and your supply chain so you produce a product that can actually be manufactured and delivered. And then learn about overall business strategy so you make sure that what you're doing is actually going to have an impact on your organization's success. So all those things are critical to actually being able to make the most of your contribution. Never stop learning. I love this quote. Deming is known as the father of total quality management. He was an industrial engineer originally. He worked with automotive companies, especially Japanese automotive companies, back in the 1950s and early 1960s. He's actually a lot of the reason why Japanese companies ended up eating the lunch of the big American manufacturers over a long period in, from like the 1970s to the 2000s, because the Japanese auto companies listened to what he was saying about how to get quality into your product, and the American companies at that time didn't. So now pretty much everybody agrees, you've got to pay attention to quality and you've got to practice good quality practices. But Deming said learning is not compulsory, but improvement is not compulsory. But in order to survive, we better do those things. So if you want to survive and thrive over a long engineering career, never, ever stop learning. and do that while you're engaged with the community. I'm a big promoter of the Association for Computing Machinery. If you're in any field that has anything to do with computing, IEEE, if you're in any engineering related field, period. But there are other professional groups that you can join depending on your field. Join them, go to the meetings, get involved. It's a great networking opportunity. It's a great way to stay up to date with what's going on in your field. Uh, Interact on LinkedIn. It's a great professional platform. Again, you can find a community on there of other people who work and post in your specialty. Look on sites like Meetup for local meetings that cater to your discipline. Maybe all the data analytics people in your area get together at a bar on Friday night, right? Um, Find those opportunities in order to make and grow connections with other professionals in your field. So how do you prepare to join the team? Again, try to be M-shaped, develop those multiple specialties, work on your soft skills, um, build those bridges to business that we talked about. Never stop learning, be a lifelong learner, and find ways to engage with your community. So join the team and get in the game. Uh, I have had a fantastic career over. I'll date myself. It's been 45 years since I started in this. Never gotten tired of it. Still doing it. Um, and I think it's going to be, but it has not worked out the way that I originally planned. Um, all along the way, there have been twists, turns, detours, but I've followed the opportunities, and I've been very happy with how well things have worked out. I learned, like I mentioned before, with assembly language, with a language called PL1, which nobody knows about today. Languages like Fortran and COBOL that you've probably heard of, and that are still out there. There's still systems running in those things. Um, but I've had to relearn and adapt different languages, different tools, different approaches over the years. But as long as you roll with the punches and you collaborate with your teammates, you're going to have a great and amazing career ahead of you. There's my contact information. If anybody would like to get in touch, feel free to shoot me an email, connect on LinkedIn. You can hop over to my website and find out a little more about me if you are so inclined. Um, and very much appreciated the chance to talk with you, and wishing you the best of success in all your careers. And with that, I will ask Dr. Tidwell to step back in, and we'll see if we have any questions.
Thank you so much, Dr. Walker. Please feel free to ask questions in the chat. I have gathered the couple that were asked, and so I'm going to go ahead and start there, but feel free to ask questions. This is your chance to network with people in the industry, whether you're in the industry or whether you're a student. So one of the first questions is, with AI coming into the woodworks of all fields, what fields are most in danger of AI takeover? And maybe since you put it in as not really takeover, but AI, using AI, would it be help desk support, coding, software developers, all of the above? Which ones are the one to jump into and learn about AI, and what types of AI would you suggest?
Um, great question. I think companies now are definitely trying to replace help desk support with AI. And I think that is in some ways unfortunate, because working at the help desk is a fantastic entry point for new technical people, and a great way for them to get a foothold in an organization. Um, but that over-reliance on AI has gotten several companies into trouble when the support chatbot hallucinates things and maybe makes promises to customers that turn out not to be true. So I think it's probably going to eliminate a lot of the what we call level one support of people calling in for routine things like password resets. But if anything, there's going to be a greater need for then level 2 type support and beyond, the humans who can intervene and handle the more complex problems. Software development is definitely already being transformed by AI. And the studies suggest there that it boosts the productivity of senior people, maybe even more than it does junior people. And so some companies, I think, are probably cutting back a little bit on hiring junior people and instead pushing their senior people to be more productive with AI to close up the gap. But you can only take that so far. So I would definitely recommend, if you're in software, get familiar with the AI tools. Microsoft GitHub Copilot is a great one that I use. Cursor is a great one, but there are new ones coming out all the time. So definitely get familiar with how to use those to augment your coding, what you can rely on the AI for, what errors that it generates, what you need to check for. And I think demonstrating that expertise, that you can be more productive with AI, is going to be the key to getting a job in anything connected to software. Other engineering fields, AI, I think, is having a little less of an impact, but it's automating a lot of the busy work, basically. And so anybody really needs to learn how to use it to the best effect in a workflow to speed up the things that frankly maybe don't have to be done all that well, in order to spend more time and effort on the things that are really creative and that do have to be done well.
Awesome. And this next question, if you don't have the answer, I'd be happy to take it. In the IT security field, what type of AI would be the most important to me?
I am not a security expert, so I will happily defer that one to you.
Okay, sounds good. So in the security field, especially in, the Security Operations Center, the biggest part of AI is the automation in the SIMs and the security event incident managers. They're automating a lot of things, and AI is able to catch attacks before they happen. It's also able to catch things and then quarantine them and then send you alerts. So you can look at Splunk has an AI system, SOAR, SOAR. Take a look at some of those SIMs. They have where it's used to be automated, but now AI is taking that automation and then acting on it. So if you're getting attacks from certain IP addresses, or if it's coming in through a certain port, it's able to close that down quickly and then send you alerts. And then it, will tell you what kind of alerts they are at the time. So just getting into the SIM management, that would be definitely a good point to go to. Next question. For Russ, with AI support growing, is product marketing and designing in danger?
Again, I think it's going to be transformed, but it's not really in danger of getting eliminated. I think people with no experience trying to talk to AI and get what they want is a recipe for serious trouble in a real product. I know startups are using, you hear a lot about vibe coding. I think some startups are using AI effectively to create either prototypes or, in some cases, maybe what we call an MVP, a minimum viable product that you can put out in the marketplace to test something and get feedback on it. But a non-expert generating a product with AI is most likely, at least currently, I think, going to generate something that is not sustainable, that has security risks, that's not going to be supportable and be able to scale. And so basically, we develop programming languages because, and the main skill of being a developer is being able to express exactly what you want a product to do in an unambiguous way. I mean, that is the central skill of a developer. And it's not a skill, trust me, that most non-developers actually have of being able to say clearly and unambiguously exactly what they want. So I think it has a role in product marketers and entrepreneurs being able to go to a certain point by themselves and maybe being able to more clearly communicate what they want with an engineering team by producing their own prototype and saying, hey, here's kind of what I have in mind for the product. Here's something that AI generated. Now, build that, but build it in a, supportable, scalable, efficient, sustainable way. Um, so it's going to change the process, but I don't think it's ultimately going to remove that layer.
Thank you. With the potential that AI has to do certain engineering tasks, what should the students do to ensure they're prepared to work under the AI paradigm?
Uh, Use it. The best way to learn any new tool is, to get in and play with it yourself. Try to use it to create a real, even if it's a small scale project. Um, and just see how it works out. I mean, there's lots of good. The field is evolving so rapidly that I don't actually think there are any textbooks that I'm aware of that are up to date, but there's a lot of information out on the internet. So I would say find some good. Again, this is where your professional associations, IEEE, ACM, whatever the associations are in your chapter, in your discipline, can really help you with sort of filtering some of the hype and the noise out. So read things in professional publications that are reliable about what's going on in the field, and then get in and play with it yourself, and see how it works and where the pitfalls are.
Thank you. As someone who is developing a new health-focused wearable, I'd like to ask, when transitioning from engineering simulations to clinical testing, what pitfalls do you often see innovators run into?
Oh boy. Yeah. Uh, Patients I mean, simulations are incredibly valuable, but patients are very different from simulations. And so the pitfalls that I've seen are largely patient behavior and patient responses. Um, Also, the medical field does not work in any rational way, honestly. And so things like, physician behavior around the introduction of a new device, if it's something that involves physicians and the clinical side of things. I don't know if this is a consumer wearable or a physician prescribed kind of thing. But a lot of things that make perfect sense in an ideal world and work well in simulations, um, run aground on, the physicians just won't adopt them. And that's sort of to some extent, outside the realm of engineering. But I would definitely, before getting too deeply into any healthcare product, um, do some serious market research on, be able to anticipate whether it's something that's really going to be adoptable uh, before you get too far down the road of actually engineering the product.
That's very good. Thank you. This is a good one. When you first started out, put in a leadership role, and you weren't 100% confident in executing a project to your team, what did you do to overcome that and still make it a success?
Great question. I mean, nobody walking into leadership, it's always a scary thing. Um, and so I would say really what I had to learn was to be able to rely on the team, that it wasn't all on me as the leader. I was pretty, that was, I think, my original mentality that kind of steered me wrong and led to a lot of sleepless nights, was feeling like the success or the failure of the whole thing was on my shoulders as the leader. And really, as the leader, it's not your job to individually perform anymore. It's to get your team to perform and to support your team in doing that. And so when I sort of let go of trying to micromanage everything and trusted the people on the team more with the details and just took more of a role of supporting them, figuring out what they needed to have in order to get the job done in the way of resources and funding and communication. Um, that was really where the light bulb went on for me that, oh yeah, this is how this works when you step away from being an individual contributor and become more a leadership role for the team.
Awesome. Thank you so much. Any other questions? Those were really good questions.
Yes, fantastic questions.
Awesome. And Mark did put that it's a PTSD wearable to reduce symptoms using EM waves, bone conductive audio, and haptics.
Ah, wow.
That
Okay,
is,
sounds fantastic. I know
I was going
there's
to
a
say
lot
that
of
that sounds awesome and it
yeah.
went right over my head.
Yeah, yeah. But
Wonderful.
yeah, definitely check out, where that would fit in the care and treatment cycle and what would be the motivations for not only the patients, but also the clinicians and the funders and everybody else involved, how that would fit into the way that they do business.